angle of sine A is 5 over 13. So I can show that on this diagram here. This is obviously angle A. Sine is opposite over hypotenuse, and that means the opposite side to this would be 5, and the hypotenuse would be 13. We would then use Pythagoras' theorem, so this would be the square root of 13 squared minus 5 squared. It's minus because it's a short side. Gosh, I can't read that at all, sorry. That's 169, take away 25, gosh, which is 144, which is 12. And we know that the cosine is adjacent over hypotenuse, which in this case is now 12 over 13. Find cos 2a. Remember that cos 2a is not just two lots of cos a, and for cos 2a we need to find the formula booklet. Okay, here we've got three different expressions for cos 2 theta, so I'll just note that. Okay, so we know that sine is 5 over 13 and cos is 12 over 13. Okay, so we know that cos 2 theta, oh, I guess, sorry, we should say A. Equals, doesn't matter which one we use, may as well use this first one. So cos squared, so that would be 12 over 13 squared minus sine squared, which is 5 over 13 squared. So that's 144 over 169 minus 25 over, oh gosh, 169, which is, oh gosh, 119 over 169. Gosh, sorry. Okay. Right, find the value of each, giving them as an integer. Oops. So log 6. So if you watch the other video, you'll know there's different ways of doing this. I try and make the base the same, so I'm going to change this to be log. Sorry, not, yeah, anyway. So I'm going to try to make this a 6, so I know that 36 is 6 squared. And then that would be 2 log 6. This is 1, so it's equal to 2. If you're adding laws of logs is that you would multiply them. Sorry, maybe I should show you that. Snip this whole thing. Just in case. Okay, so yeah, so when they're when you're adding logs, you would multiply these values here. So B would be log base 6. Oh god. Oh, 4 times 9 is 36. Okay, so that's obviously also equal to 2. And C, we're subtracting, so this is log base 6. And when we're subtracting, we divide, so it's 2 over 12. that's log base 6 of 1, 6. And then that would be log base 6, 6 to the power minus 1. Negative 1 comes in front. That's equal to 1, so that's just negative 1. Done. Alright, so we've got a general function between negative 4 and 5. Okay, write down the value of f of minus 3. So that means that the value of x is negative 3. So we find the value of x is negative 3 and find out where that graph is, and that's obviously at negative 1. Find f minus 1 of 1. Okay, so this is where you need to remember that the inverse function is a reflection of this original in the line y equals x. So let's draw the line. Y equals x. I'm hoping you would have a ruler in your exam. And then we need to reflect this line. I know that point goes there, goes through this same point. This point would be here. This would be about here. This would be here. It's a bit rubbish, but okay. So f minus 1 of 1. So we can see that that value is 0. Okay. Find the domain of f minus 1. Remember, domain are the x values. So also remember that for inverse functions, the x and the y values switch. So we didn't actually have to sketch it straight away there to answer this question. We could have also remembered that we would be looking at when x is 0, x is 1, sorry. Sorry, when y is 1. Oh, God. Sorry. End of the day. So for the inverse function, they want to know when x is 1, but what we would do if we're looking at the original function is look at the where y is equal to 1, and we saw that that was when x was 0. I hope that makes sense to you. Perhaps sketching it would be the easiest option, which is what I did to start with. Anyway, okay, so since the x and the y values switch for inverse functions, that means that the domain of the inverse would be the range of f. Okay, so we're looking at the range of f, and the range of f was between here and here. So that was the value of 3 and negative 3. So we would say that the domain of this is between negative 3 and 3. That's just a working step. Alright, on the grid above, sketch. Oh, I did that already. Okay, there we go.